The things you use every day, like refrigerator, TV, AC, phone, washing machine, all have a thing in common. They all have a processor or chip irrespective of what they do. These processors act like a brain to these devices. And these brains are made of transistors, and transistors are made of p-n junctions. Almost all devices you use every day has a p-n junction in them. So, what is a p-n junction? A p-n junction is made from a semiconductor crystal. Properties of semiconductor lies between that of a conductor and an insulator. Now, let's have a look into the atomic structure of the semiconductor. As you all know, atoms are made up of a nucleus with positively charged protons and neutral neutrons. Negative electrons revolve around the nucleus. The path of these electrons are known as energy levels. The outermost energy level is said to be in a valence region. So, we can see that there are 4 electrons in the valence region of a semiconductor. The next level is known as conduction region. If conduction need to occur, electrons should be available in the conduction region. This is the case of a single atom. When 6.022 into 10 raised to 23 atoms are piled, we get a molecule. In the molecular level, the energy levels of different atoms interact with each other and form energy bands. Thus, valence region becomes valence band and conduction region becomes conduction band. Now, as there are no electrons in the conduction band, the semiconductor does not conduct and is an insulator. But this is only when the temperature is at 0 Kelvin. As we increase the temperature, the electrons in the valence band absorb thermal energy and jump to the higher conduction band. That is, if the temperature is 300 Kelvin, which is the room temperature, there are electrons in the conduction band. So, the semiconductor acts as an insulator in low temperature and as a conductor in high temperature. The most commonly used semiconductors are silicon and germanium. Now, let's consider that our semiconductor is made from silicon. In a silicon crystal, every atom is arranged in a uniform fashion. This is because every atom is in covalent bond. That is, each atom shares electrons with adjacent atoms. Thus, every atom attains stability by having 8 electrons in the valence band. As there are no free electrons in the structure, it is now an insulator. But when we increase the temperature, some covalent bonds break and electrons are made free. Thus, it becomes a conductor. When an electron breaks from the covalent bond, it leaves a gap in the bond. This gap will show a positive charge and is known as a hole. Electrons from adjacent bonds can fill this gap and thus making the gap or hole not stationary but a moving positive charge. Thus, when an electron breaks away from the covalent bond, an electron-hole pair is generated. This electron-hole pair gives conduction ability to the semiconductor. This semiconductor made of pure silicon is known as intrinsic semiconductor. 5-Minute Study is an exclusive channel providing engineering tutorials in a unique, simplified manner. For notes, mock tests, and more tutorials, subscribe and download our app from the description below. Please like, share, and support us so that we can make more tutorials for you.